So today the student will be able to use the formula for exponential growth and decay in order to calculate amounts after a given time. So here's the definitions for exponential growth and exponential decay. So exponential decay happens, it describes the process of reducing an amount by a consistent percentage rate over a period of time. Basically what we're taking is if you're asked to find y, the final amount, then you're going to use the original amount, and then you're going to take one whole and minus the decay factor. So because we are reducing, if we just multiplied by 1, we'd have what we started with, but I need to have less than that, so we're going to subtract it. The decay factor is usually a percentage. So if I have a decay factor of 5%, that's going to turn into 0.05, the decimal. If I have 50%, that changes to 0.5. So remember, when you change a percentage to a decimal, you take the decimal where it's at in the back and move it 2 places. So fill a 0. Okay? Exponential growth is the same idea, except we are adding to one whole because we are going to grow or raise an amount. So for example, if I have, account balance, if the account starts with $100 per year, or $100, and has an annual rate of 4%, and the money is left in the account for 12 years. So y equals our final amount, the amount we're finding, the initial amount first, so 100, times 1 plus, 1 plus, because we're adding 4%, 0.04. Now it says annually, which is per year, so our time is in years, so we're to the 12th power. So then I have 100 times 1.04 to the 12th power equals $160.10. Because it's money, we're going to round it to 2 decimal places. An adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases, so it's going to be decay, by about 29%. How much ibuprofen is left after 6 hours? So, and we're saying each hour, so that's our time is measured in hours, or our x. So y equals the initial amount, 400 milligrams, times 1 minus, because we're decreasing, 0.29 is the percent, and we're looking at 6 hours. All right, so that ends up being 400 times 0.71 to the 6th power, and it's going to be 51.24 milligrams. Okay? In 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers is created by 75% per year after 1985. I think this should say increased. It's increased by. So we're adding 75% every year. How many cell phone subscribers were there in 1994? So y equals the initial amount times 1 plus, because we're increasing, 0.75. Now, we are measuring in years, right? So if I want to know what happened in that span of years, I need to take 1994, the year I want to know what happened, minus 1988 to see, or in 1985, sorry, to see how many years have passed. So really my formula is 285 times 1.75 to the 9th power, which is going to give you about 43,872 subscribers. Now, the only other kind of weird thing you might see with a situation like this is if they, instead of giving you like a 75% increase, if they say that something doubles, then let's say we have the same problem, but it doubles instead of increasing by 0.75%, then you're going to have your 285 But instead of 1 plus, you're just going to use 2. So if you double, you just multiply by that whole number of 2, don't add anything, and then the 9. So that's the only other thing that's kind of weird. If you're given a percent, you have to add or subtract it from one whole. But if you're given like a double or triple or something like that, then you just use the number that's given. And that's it.